Hello everyone, this is my first YouTube video, so I guess I need to introduce myself at first. My name is Haiying Zhang. Well, I guess you have already questions. Well, what kind of name is that? Or maybe, oh wait, what kind of accent is that? Well, I'm a Chinese and I was born in Shanghai in the year of 80s. And then I moved to France to continue my studies at my university in Shanghai. And since then, I started working in France till now. I spent some years in some operators as a network engineer or as a pre-sales engineer. And then I passed to a system integrator, and now I'm working as a pre-sales engineer in a SD-WAN vendor. This is my first video, so I guess I want to talk you about the idea of SD-WAN. But in this video, I try to be as generic, as agnostic as I can. So what is SD-WAN? Well, I will give you maybe a unique view to explain SD-WAN in some numbers, because I find many terms, many technical terms are explained in numbers such as zero-touch provisioning, and when you talk about data plan, and it comes in pair with control plan. So I will give you this kind of view in my video, and I hope you enjoy it. The first number is 0, and the 0 has to be zero touch provisioning, or ZTP. Well, zero touch is a bit exaggerated, because if you want to install something, you have to physically touch it at first. However, the idea behind the ZTP is that you can actually shift a network device directly from the factory to the branch office without any pre-configuration. Now let's see how it works exactly. So after the branch office has received the SD-WAN device, the first step will be installation. This can be done by anyone on the site, so not necessarily a network engineer nor IT staff. So this will largely simplify and accelerate the process to open a new site. And as long as a DHCP service is available on the one side, this whole process is really plug and play. So basically, you just need to plug the WAN port to a WAN device, which can be an internet box, the LAN port to a LAN switch, and of course, do not forget to power on the SD-WAN device itself. Then the SD-WAN device will try to contact the ZTP server and present its serial number and the certificate. Then it's the ZTP server's turn to do the onboarding process. So basically it will check the serial number in the database to find out to which customer it belongs. And then it will send back the URL of the SD-WAN orchestrator and send the signed certificate back to the device. Now the SD-WAN device has the information of the SD-WAN orchestrator, then it will automatically establish the secure connections to the SD-WAN orchestrator to download its network configuration, its application configuration, and upload the monitoring and the reporting data. With all this configuration in place, it will know how to establish the IPsec tunnels to the hub site or to the branch offices if necessary, and it will also apply the local security policies to secure the local internet breakouts. And the number 1 can refer to single pane of glass. To make it easy, you can consider it as a unified user interface to manage all your assets and services in your network. So it can hold the inventory of all your sites. It can centrally manage all your network configurations, security policies, WAN and application optimization features, and the dashboard of monitoring, reporting, alarming, etc. etc. For the number 2, we'll talk about two things. First of all, the two planes. So it's about the data plane and the control plane. Well, these are the fundamentals of anything that is software defined, whatever it is SD-WAN or SDN. Data plane is very easy to understand. This is how user traffic is routed, how packets are forwarded. And the control plane is like the intelligence of each network device to tell the device how to route and how to forward the packets. It can include the network configuration, the routing protocols to use, etc. Before SD-WAN, in a traditional network architecture, each network device holds actually the data plane and the control plane, which means to make your network work, you have to locally access to each device to type in the configuration. With the evolution to SD-WAN, this control plane is actually decoupled from data plane, and now it is managed by the SD-WAN controller. And then thanks to the unified user interface, now the users can configure the whole network devices via a single pane of glass. The second thing about the number 2 will be the two layers, underlay and overlay. What is the underlay? The underlay is actually the infrastructure to guarantee the end-to-end connectivity between your sites, your users, and the services. In the underlay, the network devices, they care a lot about their neighbors to find out where to send the packet. Let's take an example for a packet that is from the left side to the right side. When the packet arrives at the PE will just compare the destination IP with its routing table to find out, okay, the next hop is actually the P1 router. Once the underlay is ready, we can build the overlay. When we talk about overlay, it often refers to some tunneling protocols such as IPsec, GRE, or VXLAN, or a mixture of all these protocols. Compared to underlay, the overlay doesn't really care about the hop-by-hop routing because that's the job of the underlay. Instead, they care about the end-to-end connectivity because they want to send the packets to the destination to the remote site. In this example, for the sake of simplicity, I will use my SD-WAN device to replace the MPLS-CE, but in real life, you may want to place your SD-WAN device behind your MPLS-CE. So now let's see what changes. Still the same example, the left side wants to communicate with the right side. When the packet arrives at the SD-WAN device, it will apply the IPsec encapsulation. This will add outer IP header to the packet. From the point of view of the PE router, it will see the source IP address is actually the one IP of the SD-WAN device, and the destination is the one IP address of the remote site SD-WAN device. This is a game changer because as you can see that your MPLS operator, they will just route based on the IP addresses of the interconnection subnets. Moreover, the inner IP addresses, the real LAN IP addresses, are encrypted in the IPsec payload. Your operator will not even know what your real LAN IP plan is. This also means that you can do whatever you want with your LAN prefixes because they are invisible to your operator. You can add new IP ranges, you can modify them, you can delete them. That is how the user can take control of the MPLS thanks to the overlay. Now here comes the number 3. Some people will call it the 3 pillars, while the others will call it the 3 waves, whatever. Anyhow, your SD-WAN solution must take into account these 3 aspects, which are network, security, and application. For the network, as your SD-WAN solution will replace your current one, so it must take into account the routing capabilities. And also, as you will leverage more and more the internet, untrusted transport, that you must build your secure overlay onto it to manage your IPsec VPN. Also, it has to provide some network services such as NAT, DHCP, etc. Regarding the security, it can be achieved by many ways. Either the SD-WAN solution can provide enough security features integrated, or it can be achieved by the service chaining with third-party solutions. Moreover, today, with the notion of SASE, you can even rely on some cloud-based security providers. So the security features may include the firewalling, the URF filtering, antivirus, IDS, IPS, meaning intrusion detection or prevention. At last but not least, it's about the applications. First of all, it's the visibility. This is essential into a SD-WAN solution as we are using more and more cloud applications. which are based all on the same TCP port 443 for HTTPS. And how can we differentiate the different applications on the same port, while some are critical and the others are maybe shadow IT? Secondly, it's QoS, as we'll leverage more and more internet network, which is by definition best effort. Without all the QoS mechanisms on my MPLS network, now how can I guarantee the critical business application performance on my internet network? At last, you may want some WAN optimization features to reduce the redundancy of the data transfer on your WAN network to reduce the bandwidth. I want to talk about two things about the multi-tie. First of all, multi-tie link. This is also where the word traffic steering comes from, which is also one of the basic features of SD-WAN. With SD-WAN, you will be able to manage multi-tie links on your branch offices, which can be MPLS and the internet. And the SD-WAN solution is there to help you to steer the right application onto the right WAN network. The decision can be based on the application nature. For example, the voice traffic is more suitable to be sent over the MPLS network because you have a better SLA from your network provider. However, some file transfer and some SaaS applications may be better sent over the internet network because you have a bigger bandwidth and it's direct to internet. And then your network quality may decrease, so your SD-WAN solution must be able to detect it and decide to switch the traffic onto the other one as soon as it can. At last, I want to talk about the multi-tenant. At first, what is the single-tenant environment? In this model, actually it's very easy. Each customer will use different SD-WAN orchestrator to build their data plane. It's not suitable for the managed service because there will be huge resource waste. However, in a multi-tenant environment, the SD-WAN provider will mutualize the SD-WAN orchestrator to serve the different customers. However, the data plane between the customers are separated. Finally, let's wrap up this session to see what SD-WAN is and what are the benefits. In a single phrase, you can say that SD-WAN is a single pane of glass. If you're looking for a new job in SD-WAN, and when you say that word in the interview, you will just impress the people in front of you. So what does this mean? It means that SD-WAN is a single solution that offers multi-services. At first, it delivers SD-WAN. SD-WAN is also seen as the next generation WAN because it offers more features than your current one. Secondly, the traffic steering will guarantee that the right application is always sent over the most suitable one. Let's just remember the example of the voice traffic onto MPLS because it has better SA. And the file transfer and the cloud applications should be sent over internet because you have bigger bandwidth and the latency is lower. And then you must address the security features because when you have local internet access, you have to enhance your security on this untrusted transport. Then don't forget that you need also network and application performance monitoring and optimization. How you can identify the different SaaS applications, the critical ones, the shadow IT, when they are all on the same standard port, TCP 443. And how you can implement the QoS to improve your user experience because internet is by default best effort. Then it's about the agility, efficiency, and the resiliency. How to understand that? SD-WAN works with the hybrid WAN. By hybrid WAN, we usually mean MPLS plus internet. With SD-WAN, you have the possibility to leverage the most suitable WAN for your applications. Again, the example is voice over MPLS and the file transfer over internet IPsec externals. And then we have talked about the ZTP process. As you can see that it's really a plug and play process. It's easy and quick to roll out a new site. And with hybrid WAN, if you leverage more and more internet links, this will reduce your costs because usually internet links is much cheaper than MPLS network. Also, with internet links, you have the possibility to do the local internet breakout to access to cloud to SaaS applications more efficiently. At last, with the overlay concept, you can take the control of your network from your service provider. That is thanks to the encapsulation. Just remember my slides about the underlay and the overlay. And by adding the outer IP, thanks to the encapsulation, that you can hide your IP plan towards your service provider. At last, it's about the governance and operations. Now, more and more often, we see that SD-WAN is delivered as a service, a managed service. In this case, it means that the users don't need to worry anymore about the infrastructure, the servers to provide to install the whole orchestration platform. Moreover, when your network grows, you don't need to worry about the scalability of your orchestration platform because they are managed by your service provider. And as they leverage cloud, so they don't have any issue to extend to scale their infrastructure. Another advantage is the maintenance. So now it's up to your partner or to your service provider to keep the latest versioning of your SD-WAN solution. SD-WAN also allows easy and simplified service delivery process to open a new site. Again, thanks to the ZTP, you don't need to send any more local technical stuff to open new site because everything is managed now in a centralized orchestration platform. At last, SD-WAN is also the place to do the monitoring and the reporting. You can show to your end customers, to your management, that this SD-WAN solution achieved its goals. So what's the final goal of SD-WAN solution or of any network solution? It's to serve the applications to guarantee to improve the user experience. And how you can justify that in front of your management? It's via the monitoring and the reporting tools. Okay, so that was my first video and I hope you really enjoyed. If you like it, please click the like button at bottom of my video, depending on what kind of application that you're using. And you can also subscribe to my channel. And if you are numerous, I will try to put more videos, not necessarily technical ones, into my channel. And at last, I want to pay my respect to the Black Panther. Wakanda forever. See you next time.